Okay, so we're going to do that again. So prove by induction the following. And of course, if you're in an exam, you know this is an inequality because of the greater than, less than symbol. So we know that is the kind of type of method we have to use. So we start with our usual PN is just repeating the question. So we're just kind of starting off. That's our starting point. Usually then we do P1. We prove P1. Now, the reason I can't use 1 is because the condition says n has to be bigger than or equal to 3. You can choose any number you want, but I usually will go with the lowest one. So I'm going to go with 3. So let's fill in 3 and see if indeed this is true. So I do 3 squared is 9, and this becomes 3 plus 4, 3 plus 1 is 4, sorry, squared. So that's 18 is bigger than 16, tick, that is true. So it implies that that is definitely true. So we've done that step. The next thing we do is we usually assume PK. In other words, we replace every n with k. So we repeat the sentence, but anywhere there was an n, there's now a k. So we might even just tidy that up a little bit. So that would work out as k squared plus 2k plus 1. Okay, just multiplying out that bracket. Now, that is what we call our assume sentence. Now, the next sentence is prove k plus 1. So anywhere there was an n, we are now putting a k plus 1. So everywhere there was an n, there is now a k plus 1. So I'm just going to tidy this up before we do any more. So k plus 1 squared is going to multiply out to be k squared plus 2k plus 1. This is going to be k plus 2 squared. So we might as well work that out as well and just kind of get it as simple as possible. So what will that be? K squared plus 4k plus 4. Okay. So we have our assume sentence and we have our prove sentence. Now, when we're doing proof by induction for inequalities, the key message is, again, it's written at the top there of the page. You should have all that written since the last day. We want to somehow change our assume to match our prove. That's the key sentence. Change the assume to match the prove. So let's check out what our assume is and what our prove is. So where I have my yellow highlighter, that is my assume. But I would like my assume to look like my prove. So what's the difference between the assume and the prove? Well, it looks to me like I would need to just add a 4k plus 2. So onto my yellow, I am adding a 4k plus 2. Now, if I do that on the left of my yellow, well, then I have to do it on the right of my yellow. So that is why I am also adding a 4k plus 2. So I'll say that again. I look at the yellow and the pink and I ask myself, how could I make the yellow into the pink? To make yellow into pink, I would need to add a 4k plus 2. If I add it on the left, well, I also have to add it on the right. So just tidying it up somewhat, I have k squared plus 6k plus 3. Now that's kind of the best I can make it. Now, how do we piece it together? Well, we piece it together by saying this is true if, so this is my true if sentence. It is true if my adjusted assume, I'm calling this my adjusted assume because it's the assume sentence adjusted. So it is only true if my adjusted assume is bigger than my prove sentence. So my prove sentence was the one above. Okay. So does my left-hand side, does that look bigger than my right? I think we can all say straight away that it does look like it's going to be bigger, but it's nice to just kind of double check. So remember, the restriction was n had to be bigger than or equal to 3, which means k has to be bigger than or equal to 3. So let's try 3 and see if it makes sense. So just filling in my 3 and seeing if it makes sense. So 9 plus 18 plus 3, 9 plus 12 plus 4. So what's that? That is 20, that's 30. And that is going to be 16, that's 25, isn't it? So we will end up getting 30 is bigger than 25. That is true. Okay, we now know that it is true. Now, it is true as, so true because, in other words, true as k is bigger than or equal to 3. If that restriction wasn't there, it wouldn't necessarily be true. Now that I've shown it to be true, I can just kind of clarify and go back to my prove sentence. My prove sentence was that 2k squared plus 4k plus 2. So my last black sentence, in other words, 2k squared plus 4k plus 2 was bigger than k squared plus 4k plus 4. Now, when all of that is said and done, I go therefore pk plus 1. So my little generic sentence is true if pk is true, and that implies that pn is true for all n is an element of n, with the restriction where n is bigger than or equal to 3.